daytime astronomy, right? Okay. Sorry. Okay. So the idea is daytime astronomy. That's what I'm going to be talking about it for the next for tonight's topics. But hold on. You assume that I'm going to talk about the sun. No, I'm going to talk about imaging planets in the daytime. Daytime planetary imaging. That's kind of weird, right? Because usually you observe the planets at night. But there are reasons why we must observe the planets during the daytime if any particulars or any particular events are taking place and happening in daylight, in our time. So that's what that's what I'm going to be talking about about daytime planetary imaging. So. Uh-oh, warning. Well, what that means. Of course, during the daytime, you have the solar precautions. So observing at the daytime, you have the sun in the sky. So let's find out, what that means by solar precautions. If the object has less than 35 degrees of separation from the sun, you must exercise safe practices to avoid permanent injury to your equipment and, most importantly, to your eyes. Okay. Try to place the sun behind an astronomical so you are set up in the shade. In other words, if you plan to observe the planet during the daytime, it's a good idea to set the telescope in the shade, out of the sunlight. Now, when it's in the shade, probably could be the shade of your house, or maybe the roof of your house, or a building, or even the trees too. But as long as it's in the shade, so you prevent the accidental pointing toward the sun. So always in the shade. Now, what are the advantages and disadvantages of imaging the planet in daylight? Well, we'll find out. Okay, first, the advantages. Here are the list of the advantages that I'm about to show. Imaging can be done in daylight. Okay, that's what we're talking about. You don't lose any sleep. Now, that's my favorite part, but you don't have to be late at night, then you lose the sleep or get up very early in the morning before sunrise. So, yeah, during the day, just a normal hour, just the normal activities during the hours. So you don't have to worry about, losing the sleep. Of course, the planets are bright. You can image the planet in your backyard. So you don't need to go any place else or go to the park or go to your observing site or go to the beach. You can do it from your backyard. No need to escape light pollution. So no matter how much light you have in your area, the planets are always visible. And in the daytime. Okay, so there's no need to escape light pollution to get away into the dark. It's not necessary to go to the darkest sky to observe the planets in daylight. And most importantly, anybody know? Let's take a wild guess. Observing the planet during the day? Anybody? Okay. No mosquitoes. Yes, no mosquitoes. So, you don't have to worry about that. If they're late at night, you get bit and so forth. So that's pretty pleasant. Uh-oh, here's some disadvantage also. The sun causes blindness if you're not careful. The scope must be in the shade, as I specified before, and I have to be very careful. When the sun is up, make sure the scope in the shade. You will run into atmospheric disturbances. Okay, now as the sun rises in the sky and heat up the atmosphere, then you're going to run into some turbulence. So that means the sea condition probably will be below average, maybe, or nearly average. So, so the the later the day, the more turbulence you're gonna see it. The cloud may build up through the day, of course, with the heating effect. Once the sun heat up the atmosphere, then you have the cloud build up. Mainly it's in the afternoon, but if you can get away with it in the morning hours, you get less clouds. So the later you wait, the more clouds probably will build up. And the wind may pick up, right? You know, the morning hours, it's the winds is nice and still, no winds, or maybe calm. Then the wind may pick up as the day progresses. Your scope cannot be in the sun during the planetary images, like I specified that before. So, okay, here are some of the things that then I'm going to be talking about it. This is like breaking down the subtopics. So what I'm going to be talking about in order to cover it. The telescope alignment. That's very important. Make sure the telescope is aligned in the daytime when you're trying to find or observe the planets. I get more detail to that. Center the target. So once you find it, the target that you want to observe in imaging, make sure it's in the center and do not lose it. Focusing, that's very important. If you're not sure if the scope is focused, then you have a problem. Unless there's the moon in the sky or so forth, but I get to that after that. Filters, very important. Filter, you work with the contrast and all. Brings out the features that it won't be visible in other type of filter. So I'll be covering that also. Then, once you consider all this, then the payoff, and I'll show you some of the examples, some of the images that I took in the daytime hours. So, okay, early rising approach. It's a nice picture of the crescent moon and all. But the idea is, if you want to observe the planet during the day, it's maybe a good idea if you get up before sunrise and you set up the telescope, make sure it's aligned. Put the tripod and the scope. So make sure that the polar alignment, and you can see the stars, then you can check, make sure there's no drifting north or south. Yeah, then you wait until sunrise. And after sunrise, if there's any planets you want to observe, or that something, the event is going on, then you know that the telescope is in alignment, then you can able to find the planet easily. Watch a probe is arrived before dawn and perform an alignment in advance of your daytime observing sessions. Okay, so that once again, set up the telescope before sunrise. You get the stars, and make sure there's focus, make sure there's polar alignment. Then you're all set after sunrise if there's any planets you plan to observe and image. This is easy. It works especially well if you are planning to image your target later that morning. It may be that you are already established just where and how to place your legs of the tripod to ensure a reasonable or accurate polar alignment. Now, once you're all set and in the polar alignment, then you're all set. Well, there's more to that. Okay, now if it's not, there's an option. Align your telescope the evening before and mark the position of the lake. Okay, for example, like if you're planning like the next day, or you want to observe Venus in daylight, so what you want to do is to set up the telescope the night before, and you set up the tripod, similar like this. Then you mark on the grass here with anything that you do it. If it's on a grassy surface, something like a metal stack or even a small rock, and put it where you put the lake with the tripod, and you put some kind of mark in the greatest surface. Then if you cannot leave the tripod overnight, then you can take it in, and the next morning or during the day, after sunrise, and you see those marks that you made, then you put the tripod there, and assuming that the telescope, once you put the telescope there, you assume that it's properly aligned. So that's what it is. Now, if there's no grass, if it's just on a hard surface, maybe like on the driveway or on the deck, a piece of chalk can also work to show where the lace must go to achieve a reasonable alignment. So a piece of chalk marked down on the ground, like on the driveway or on the deck, and if you cannot leave the tripod overnight, then the next day you put the tripod exactly with the mark, and you're set, and it's already polar alignment. So if you have, of course, if you have an equatorial mount. No. Okay. Focusing, that's very, very important. Well, make sure the scope is in focus. Now, I have a problem with that a couple of times when I was looking for Mercury, and I assumed that it was in focus. It wasn't. It wasn't even, and I cannot find it. It wasn't even there. So the idea is always make sure it is focused. But there's the problem. If you cannot find a focus with the crisp blue skies, you have no reference to focus an object in order to find your target. Okay, you cannot focus your scope against the bright blue sky. You can easily sweep the target without even knowing it if the scope is not in focus. So if it's way out of focus and you're looking for maybe Jupiter or Mercury, you sweep by when I even know it. Okay, so how do you try to find out if it's focus, if you're trying to get a focus? Okay, if the moon is an excellent target to focus your scope, if the moon is in the sky, you can focus it, and that's it. Then you're halfway there. Now, if not the moon, Venus can be easily seen naked eye if you know exactly where it is to get the scope focus. So if your Venus is on the same part of the sky where your target is, you can able to focus Venus, then that's it. Do not touch the focus knob. Now, if it's none of them, if it's no moon or no Venus on the side of the sky where your target is, a distant plane with the contrail might get the scope closest to focus. Now, I've done that before. If you're lucky enough, you see a distant plane with a contrail, then you follow the smoke and you get a focus. All right, but probably it's not 100% or not perfectly focused because it depends on the distance. If it's overhead or all the way closer to horizon, where you find the jet contrail, it's close enough. So you should be hopefully that you will be able to find the target much more easily. Okay, they are additional options with the focusing. First, get the scope focus the night before and don't touch the knob after that. So in other words, if you don't know exactly where the focus is, you can do it the night before and focus any of the stars. Okay, once you get a focus, that's it. Do not touch the knob, the focusing knob. And use the same eyepiece. I forgot to put that in. Use the same eyepiece. So if you have a 20 millimeter eyepiece and you focus it, that's it. Use that eyepiece, no other set of eyepiece. Otherwise, it will be out of focus. No. But beware, once you get that focus the night before, it may not be perfectly, like the next day, the scope may not be in focus due to the different air mass and different temperatures. Just hope that it will be very close to focus. So in other words, the next day, you see a different part of the air mass, and that can throw off the focus. So of course, with the cooler temperature and the temperature change, of course, the focus needs to be changed also because a different layer of temperature layer. So it won't throw out too much of a focus, but it'd be like a small blob instead of perfect focus. So you're able to find it. So, but it would be close enough. So. Now, another option is some telescopes have a focus meter. Mark the position of the dial number, and you will know that it's the perfect focus for one selected eyepiece that you use, and do not move the knob. Here's, for example, here's one of the focus meters. You see all this meter right here? So if you turn the knob, it goes up and down, then you can mark exactly where the perfect focus is according to the eyepiece that you use or you're planning to use. So once you get a focus, do not touch the knob, and that's it. So that's one of the options there. Now, secondly, the electrofocuser might help too. Focusing the target on the computer screen will help you to speed up the imaging session. It's not like you have to go back and forth and check here, no, it's a little blurry, and then you go back. So with the electrofocus, you can watch the screen, sit here while the scope is there, and then you can able to focus there. So that's the nicest way to speed up the observing session and the imaging session too. Find the scope, that's important too, but that helps you to find an object in the main tube, the main scope. Before you start, it is a good idea to align your finder scope so that when you have a target, it's in the crosshair. It also should be in the eyepiece field. Of course, you always make sure if you have the finder scope aligned so you can able to find the object easily in your main tube. I'm not sure about the what the other one? What do you call that finder scope? Tail rod. I don't know how well is that good if you find objects during the day. So let me go further. Now, what targets are usually visible in the average finder? Now, the average finder probably is 6 by 30. Okay, with 6 time with 30 millimeters. So that's pretty much average size for the finder scope in most telescope. Now, is Venus visible in the finder scope? Yes, it's a double yes. No, if of course it's visible in the naked eye, it should be visible easily in the finder scope. What about Jupiter? Jupiter, yes, too, but it's only one yes. But if you know exactly where it is, if you know Jupiter exactly where it is in the bright blue sky, then it may be visible. Yes, it may be visible in the finder scope with the -2 magnitude, so it should be easily visible if you know exactly where it is in the sky to find it to get it in the finder scope. You know, if they get into the main tube. What about Mars? Well, there's the yes and no. Yes, if it's within a few months of opposition, when it's the brightest, like -1 to -2 magnitude, so it would be visible in the finder scope. If you know exactly where it is in the daytime, it should be faintly visible in the finder scope. Now, no, it would consider when it's closer to the sun, maybe like first magnitude, it won't be visible in the finder. So, yeah, so within the first few months of opposition, Mars is bright enough to be visible in the finder scope in the daylight hours. Now, what about Saturn? No, Saturn's not visible in the finder scope during the daylight. What about Mercury? No. Okay. Filters. It's very, very important because they help you to see better and they help you to get better images. Filters that are useful for daytime imaging. I have a list of filters uses that are needed when imaging in a bright sky. IR, infrared, long pass filter, deep red are the most common and affordable. Now, what I mean affordable, I'm not talking about like a Johnson photometric red filter that can run to a couple $100, but a long pass filter, beta type of filter, is what's it, about $40, $50 the most. So it's very, very useful for imaging planets in the daytime.
And also camera filters.
Camera.
Filter that you put on the lens of your camera.
Oh yeah, yeah. But like Draken 25 or something like that. Yeah, yeah. Draken filter. Yes, yeah. If you don't have any specific bandpass filter, like long pass or something like that, I get to that. Example of okay, like Bata 610 nanometer or 685 or Astronomical Pro Planet 642 nanometer. That's one I have. They're very good. They're very good. The long pass filter. They're very useful for planetary imaging during the day. Okay, now Raton 25 filter is fine if there's no other choice. So if you don't have any of these specific long pass red filter, if you have Raton 25, it's just as good. Raton 25 is much broader red light filter than other type, but still, you get a good result. Infrared is not as impacted by the atmospheric turbulence. Well, that's very good because it helps to compensate the seeing condition. So if it's below average, the red filter helps to compensate the seeing condition, so you get better imaging. So it's not as effective than when using other type of filter, and you get bad seeing, and the vision won't come out good. But the infrared is able to penetrate through much of the atmosphere and compensate the seeing condition. So that's very good to use that. But if you have ultraviolet, UV ultraviolet filter, it's amazing for high resolution sulfuric acid cloud structure in the upper atmosphere of Venus. So you use ultraviolet filter for Venus when it's much higher in the sky, because the ultraviolet light penetrate much through the atmosphere when it's nearly overhead than when it's much low in the sky. It won't penetrate much to the dense part of the atmosphere. That's why you notice that when the sun gets low in the sky, it appears reddish because the blue light absorb it. So it's the same thing. Like if you image in Venus when it's low in the sky, even during the daytime, then it won't be as bright. Then you need a longer exposure. Then you're going to run into more seeing problems. So it's better to image in Venus much higher in the sky using the ultraviolet filter, and you use shorter exposure. Deep red filter at 100 nanometer or 1 micron can register the thermal emission from the Venus night side. So it penetrates to much of the night side of Venus of the surface. I will show you more about that. And also you can take it in daylight too. Now, if you can see the target in the field in a low power eyepiece, you can center it and then pop in the camera to focus. Okay. So the satellite is you're more ready. Once you verify all of the things I show you, then once you have that, then probably you're all ready to get the image going. Okay, this is my typical setup at home. It's a 10-inch meat, and you notice I have the dew cap here because I always use the dew cap, even during the daytime. Not because if the dew is going to blow up on the corrective plate, but to avoid stray lights from the surrounding area. So you can only concentrate the light when I'm pointing, not from the side. So I always use the dew cap. And that time I was observing an imaging Mercury. Right. Now, what the telescope pointing is pointing towards south. Now, to see the way I set up the telescope, on the side of my my side of the property here, where I live, pointing. This is pointing south. Now, Mercury, well, I think it was Venus at that time. It was right up there, and the sun is behind the roof of the building. Okay, so I was in the shade. You can see the shade here, and you can see the sunlight here, right there. So there's sunlight here, and I'm in the shade, and it's behind the roof, and I got Mercury, Venus, just on the clear, open window area, so I can image it safely. So not only Mercury, Venus, but even Mars too, or Jupiter, when it's very close to the meridian, right here. Yeah, and this is the east side. Unfortunately, I don't have the good east side, but I can go on the other side, on the front side, but I got trees there. But this is more of an open area here. So, now, I only can go this close here on my terrace because I have a computer in here, and I only can go up to 15 feet. The wires, the cable wire can go up to 15 feet, but I can't go further out yet. But unfortunately, the cable wire is not long enough unless I have a laptop, which eventually I would get in the near future. That's what I can go further out and have more of the east side here. And I'm clear on the west side, and I'm clear to the south side. So that's an ideal spot right there. So once I have everything already, so let's begin to see what I have accomplished by imaging the planets during the day. Okay, now all the pictures I will show you, note that all images that you will see here were taken in daylight. No nighttime, midnight sky, or whatever, all in daylight. You should be surprised how well the imaging, the target comes out. Okay, I'm going to start with Mercury. Here's a shot of Mercury. Taking a quality image of Mercury, it must be done in daylight during the morning apparition. Okay, here's my image here. And this is Wind Jupiter simulator. So this is what Mercury should appear on the day I was observing. Okay, and here's the filter to use. This is 10 here. And notice, this was taken 14 hours and 12 minutes universal time. So if you convert it to the local time, it's 10, 12 in the morning. Okay, Mercury was close to the meridian while the sun is still low in the east sky. So this is the best way. This is the best way you can take images of Mercury. And here's some of the details here, and this matches very well here. And so that's the idea. It's the image of Mercury in the daytime. There's no way you can get the quality image like this when it's much lower in the sky, or even when it's visible with the naked eye before sunrise. No way. It must be here high in the sky. Now, probably this was May 29th. It was at least 70 degrees above the horizon. Well, most of the time, Mercury is visible when it's 10 to 15 degrees above the horizon. And so this is the only way, if you want to get most out of Mercury, even go after the details on the surface, this is the best way. So I have a couple more charts. Usually the angular separation from the sun cannot exceed 28 degrees. So in other words, Mercury is within 28 degrees of the sun on both sides, morning and evening. Be prepared to take advantage of the short window opportunity to image it. Well, because it's closer to the sun than any other planets when you observe them. In the daylight, or even though the telescope is in the shade, you have a small window of opportunity because the time goes quickly when you're trying to image. You try one, then another session, and another session, and you want to make sure it comes out good. And all of a sudden now the sun is out, they hit the telescope. Now you get the heating effect. So that's it, you're closer. So that's why you have to prepare well in advance when you have a short window of opportunity to image Mercury and you're trying to get the best shot as possible. Hit another decent shot here. These are ray craters here, right here. And you can see one right here, this one here. Now, you don't actually see the crater itself, but you see the impact effect, and you see the rays here. But the craters are very, very small, but you won't see it. But you can see the rays here. It's very similar to what you see on the moon. Tycho, Copernicus, they have rays there. If you look through the binoculars, you can see the rays nicely. Tycho rays stretching nearly across the moon. But even Mercury too. Here. It's on down here. There's another one right here. Go to the limb and so forth. So that's what I mean to take the best image possible during the daylight. Here's another shot. Of course, I stressed before 610 nanometers red filter that I use. Any kind of red filter, you don't have to be the one I'm using, but any kind of red filter, long pass filter, will do the job. Like I use the better long pass to 10 or even 685. 685 nanometer, it's a little denser. So that means you have to increase the exposure a little bit more to darken the background and increase the contrast on Mercury's surface. A Raton 25 filter is fine if there's no other choice. Look how dark it is. Look how much contrast here. You don't even know it's daylight. You think it's taking place at nighttime. So these are the when Jupiter's stimulator. This is actually imaging the day I was serving from the Messenger spacecraft. So they make a global fuse. Then what I did here, I blurred a little bit to equivalent to the resolution of a 10-inch telescope. So they can match my images close enough. So you can see some of the details here. There, this one right here, this, and the clearest one here. This is dark, double floor crater right here. And when I blur it, you see a little blurry spot, and you see right here. And it matches very well, very consistent with one another. So that's what it is. That's the whole purpose of it. You will never get a quality like this when it's much lower in the sky. So, yes.
What year is the Messenger mission image taken from, or the reference?
It orbits around Mercury, if I remember correctly, in 2011, and it lasts until 2015. They have the spacecraft crash on the surface of Mercury.
So if there's any new changes, you would see that in comparison to the
well, it may be a change in the way from where the sun, the face angle of the sun, I've seen from Earth, to see if there's an albedo change due to the different angle from the solar angle from the sun.
right,
So,
or if any changes had occurred on the surface of Mercury, or if there was an impact.
well, it's that could be quite unusual if that happens. If sometimes if there's any spots here that I've seen in my image, it doesn't match here. It could be new or something, but unlikely it's not happening. But the only thing I can see to change, if you observe certain angle, the solar angle from the sun as seen from Earth, and you look at another time, a different solar angle, then you have the different variation of the albedo vision. See, sometimes maybe it's brighter when the sun's shining from this angle, or dimmer or brighter yet if the sun shines from the other angle. So that can be done, but you have to follow up in numbers of times, see if you detect any changes. So, but as far as its impact is something, it's most unlikely. Okay, now we move over to Venus. It wants to Venus, and of course, Venus is the easiest planet to image in the daylight because it's easiest to see in the finder scope. It's visible with the naked eye. Catching it high in the sky improves seeing. Of course, with the higher in the sky, the seeing will be better, and you can take better images of Venus. The ultraviolet light here, and it's the infrared light. So you see two different layers of the atmosphere. The ultraviolet light concentrated on the upper part of the atmosphere of Venus. Now, the infrared light, it penetrates the upper part of the atmosphere and concentrates in the middle deck. Now, the middle deck, the details of the middle deck are much different and have no relationship to the detail you see in the ultraviolet light. But there's more to it, but I don't want to get too much specific about it. But the rotation periods independently from the ultraviolet light, because it had like a super rotation of 4 days, and the infrared, the middle part, it looked like it rotated 5 days, so it's a little slower there. But the contrast is very, very low. You can able to see it, faintly, and it's hard, you need to follow up on that. Here's another shot. Using the ultraviolet light, we can image the structures and patterns of the sulfuric acid clouds lying high in the atmosphere. Here, you can see it has a cap here, another cap here, the polar region, a cap here. Now look at the difference with the infrared. So it's different. They got different patterns because you're looking at different structures in the atmosphere. And using this method, it can be done in daylight easier. Look at it. Look at the ultraviolet here. Take a dye and those contrast, and look at the infrared too. And you'd have no trouble with the background light using these filters. Here's another shot here. It's ultraviolet light here. You can see some of the detail. Look at the infrared now. There's a little dark spot there. Yeah, and it's like it changes every once in a while. And this is nothing related to what you see here. It's completely different pattern. So this is the nicest way it can be done in daylight. So you don't need to do this when it's much lower in the sky, because you won't get a quality of the image like this. Only when it's high in the sky, which means daylight. So yeah, like infrared light, delicate feature can be captured in the middle cloud deck, especially during the better seeing condition. So you can see some of the details here. Okay, Venus complete halo. Oh, what's what that means? When Venus is near inferior conjunction, it can either pass north or south of the sun. So, for example, on January 8, 2022, Venus was just 4.8 degrees north of the sun, about less than 4 hours from the exact inferior conjunction. It would take 1 hour before sunset, when the sun was behind the roof of the house across the street from where I live, and Venus was just above the clearest area. Again, the red filter is not used. So this is about 4 hours before inferior conjunction. Venus was 4.8 north of the sun, and look at the crescent here. This is overexposure. All right, the crescent actually is very, very thin, like a hairline thing. But this is overexposure. The reason I did that, because I have a chance to capture the halo right here. Now, this is the atmospheric scattering from the far side of the limb. And this is a very high upper atmosphere of Venus is scattering the sunlight. Yeah. Now, this is the positive and the negative. Why is it negative? Because sometimes you can bring out fainter details, and you can see the halo right here. Now, sometimes when it gets really close to the sun, maybe like 2-3 degrees, you got a better chance to get the halo. But this was 4.8, so it's a little further away. But lucky enough, sometimes it can create a halo, backscattering light in the upper part of the atmosphere. It could be seen. Now, the red filter needs to do this because it increases the contrast. Now, I have trouble with the background light here because it was very low in the sky, very close to the sun. So you got to make sure the sun the sunlight is not hitting the telescope, which is behind the roof. So I had a clear spot. The Venus was in the perfect position in order to do something like that.
Right.
Yeah.
I just want to say that's a really cool photo.
Yeah, I think so. Yes. Yeah. And of course, this was published in a public in the Apple magazine. And you can notice Now, if I have a normal exposure, which I'm gonna put it here, it just look like a hairline, but you weren't able to make it out. So then you need a longer exposure. Now, naked eye, it was, I don't quite see. I haven't got time to see with the naked eye because I had just like a few minutes window, to do this. So I had it just on time. Right. Okay, now being a dark side. Okay, that's another. Now, during the crescent phase, Venus night side, which is facing us, can be imaged just around sunset. So it was barely daylight. So I throw that in. So it's still considered daylight, but it's actually sunset. So the sky was still bright. A deep infrared filter at 1,000 nanometer or 1 micron is the must. With this filter, a thermal radiation, emission radiation, which is hot enough to glow when it can be imaged on the surface. So this is the Windows simulator. This is how thing Mercury Venus crescent is. Now here's overexposure. So the daylight portion of the crescent swells up in order to capture the dark side of Venus right here. You can see here, right here. So sometimes if it's clear enough, you can able to detect some of the dark and white patches on the surface. Now this is actually the surface because it penetrates a window. At this wavelength of 1 micron, it penetrates to much of the atmosphere on the dark side and concentrate on the surface because the surface is hot enough to glow, and the result is the thermal radiation. So with this filter, you can able to pick it up. So here, you see this here dark side is this one right here. This feature here, they have a higher altitude. They call beta regio. That's the type of version was built by the time. It has a high altitude. Now, with a high altitude, it's cooler, which means it makes less light. When it's less light, it appears darker. So that's why this was picked up because it's a lot cooler and it makes less light than the radiation, the glow of the radiation. And you can see several dark side here. And I took several shots and they all look the same. This probably corresponds with this. Not very sure, but this is definite there. And a lot of images, a lot of planetary images got the same thing here with this dark. It's easy because it's much darker. So anyway, so this is one of the nicest features, nice thing to do when it's close to daylight or sunset. Okay, Mars. Okay, daytime imaging make it possible to capture the early to late station of Mars apparition when it's light at least 40 degrees of the sun. Okay, at that time, Mars was about 45 degrees of the sun and 5 odd seconds. So it's really on the far side of the sun. So it appears smaller. But if you know to take in a daylight, if you know exactly where Mars is, by using using the moon as the guide or Venus as the guide, you set up the coordination, use setting circles like right ascension and declination. Do you mark them like if you observe Venus, if you mark down the declination and the right ascension, you set up the coordination, and then you have Mars coordination. Then you're able to determine how far you have to move the scope in order to locate a Mars. Yeah, so the reason is because Mars, you won't get a quality image when it's much lower in the sky. So it has to be higher up. So that means daylight, and Mars is a little difficult to find it because it's fainter. But if you plan it well enough, you can able to be successful. You hit another shot. The ability to view higher in the sky with less atmospheric distortion makes it easier to work with this tiny disk, 4 to 6 odd seconds, the disk. So at that time, this is 5.6. And look at the detail here. This is black and white, and this is color. Now, if you notice color, you pick up a little bluish tint here. Okay. Now, the seeing conditions are so much better when it's high, when Mars is high in the sky. You pick up the details. You pick up Solar Lucas, which is the eye of Mars. Yeah, invisible, and same thing with the color image. So that's the best way to go after these features when Mars is much smaller. you need to do some imaging, you have to be high in the sky. Yeah. Okay, it's another picture. Now, the dust storm, there was the dust storm at that time. Mars must be imaged every way it's possible. This means daylight. So I cannot get any image like this in the daylight when it's low in the sky, so I have to make it when it's high in the sky. So here you can make it on some of the dust clouds, and here's the time too, and through the short animation, you can see the details move, you know. So in order to track, you know, the dust clouds and all. Okay, Saturn. Now we move to Saturn. Okay. Last December, Titan shadow transit happened in the afternoon, our time. Saturn was very faint due to the lower contrast, but using the red filter and by using nearby Venus as a guide, I was able to find Saturn and document the event. Now, why I did this? Because it was Titan shadow right here. It's Titan, it's a shadow right here. This is one of the earliest images when Titan shadow event started, which is started in November, and this is probably the second passage. The first time it would skim right along the southern edge. Now this second time, December 6th, and you can see it's just skim along the southern edge. It's Titan in the shadow. The sun is shining from the upper left, from this angle. So this was taken in the afternoon. 20 hours, 21 hours, 19 minutes, that the sun was still above the horizon. Then I took another shot, and you can see it move a little bit. So if I would have waited after sunset, the transits would be all over. So I would have missed that. But that time, Saturn was right in the meridian. Now, how can I find Saturn in the daylight there? Well, I used Venus. Venus was up. I set up the Venus using the right descension and the declination. Once I got Saturn coordination, then I able to swing the scope over to Saturn. But with the low power eyepiece, I found it within a minute. That's not bad. Then once I minute, it was there. It was very pale, but with the red filter, using a black and white imaging, it just stands out beautiful. And I got captured the satellite. So that's really successful. Now, another shot, 2 weeks later, Titan shadow transit usually occur repeating almost every 16 days, slowly taking place earlier with each passage. So another shadow transit took place in the daylight. So this is 2 weeks late, 16 days later, December 22nd. Now here it is right here, shadow right there. So again, if I would have waited after sunset, I would totally miss it. So now this is the third passage. Now you can see now it's getting closer to this here. Now it's over here. So the one that's coming up on Sunday night, December 5th, 6th, it would be right here. So the transfer would be all over. So anyway, this is the earliest, one of the earliest passages. Okay, now it's another shot. This was taken last July 18th. Now, this was taken during the morning twilight. Okay, now daylight, I continued the daylight because the transits were still going on. And the daylight hours, this is 9:44. That means it was 4:45. It was already after sunrise, 4:45 in the morning, and this was taking right before 7 o'clock. The sun was it's already up an hour and a half, and you can able to see it still follow the transit. Now look in the background. Now it's getting lighter. All right, because Saturn's much fainter, so I have to increase the exposure. When that happens, then you get the background too, but you can't help that. But with a little processing, you're trying to eliminate the background as much as possible, but still, I still got Titan here in daylight. And here's the shadow right here. You can see it move like close here. So it's not the advantage of taking planetary images in the daylight for this purpose. Otherwise, I wouldn't take an image of Saturn. I do that when it's dark or at night. But during the daytime, when the special event taking place, you want to take advantage of this. So. Now, this is color. So you pick up the bluish tint here. So the black and white is always better because you got a better contrast. Okay, hold on. There may be more. Okay, Jupiter, I haven't image Jupiter in the daylight because it's really nothing specific event taking place. So really, I don't really do that. Like Saturn is because of Titan transits that I did on data, but not Jupiter, because unless there's some kind of specific event taking place, it must be done in daylight to see it. But okay, we forgot two more things. Everybody know what two more things? The sun, of course. All right, well, it's not got to do with the planets, but it's another object to observe in the daylight hours. You got the sun. The sun considered one of the solar system objects that can be imaged in daylight. Of course, you see the sun in daylight, not at night. So here's some of the images I took. Here's the night blue prominence right here. So there's not activity to do in the daylight hours. You got the total eclipse. Remember on April 8th of last year? It's visible in the daytime. You got the eclipse. It's the little diamond effect. So in order to detect, to capture the particular event taken in daylight. And of course, you have the moon. The moon visible. Here's my decent shot. Of course, you got the bluish tint here. So the moon is always visible in daylight, no matter what its face. It can be an excellent guide to find planets against the bright blue sky, especially if there's a planetary conjunction. If there's a nearby, if the moon is close enough to Venus, maybe even Mercury, or Mars, or Jupiter, or Saturn, but any chance, you can easily target the planet, just nudge the telescope in any direction where the planet might be. So it could be up here, there, so it's close enough. So you're able to find the planet much easier if instead of if the planet just stands out alone in the sky. Okay, so imaging the planets in daylight is not hard to do if you plan it well in advance, as long as you do it safely and using precaution against the sun. That's it, folks. Well,